Hello students, in my last session we have discussed about laws of logic, fundamental laws of logic. I have discussed about contrapositive, converse, inverse. Also I have discussed about a very important property, negation of conditional, right? So keeping all those laws and these two properties, we will start with the question. Now my first question is, you have to show that this proposition is logically equivalent to P and negation Q. See, if I am not mentioning use the laws of logic, you can do it by truth table as well. But now since we are practicing laws of logic, we will do all the question by using laws of logic. Now in the first bracket, I can't see anything great, but in the second bracket, I can see the negation. And we know that if negation is there outside the bracket, De Morgan's law is something which I can apply. The De Morgan's law states that negation of P or Q is equal to, logically equivalent to negation of P and negation of Q. So this law now I will be applying in my question. So let us work on this. So in the second bracket I am going to apply it. So P or Q I am not touching, and now look here, one proposition, other proposition and or, and this negation is outside the bracket. So what I will do, negation P, and this will become and negation Q. De Morgan's, reverse the sign, right? So I apply De Morgan's. Now the next thing is, I will apply double negation in this term. So P or Q and P and negation Q. Correct? Now if you observe carefully, I can see this is one proposition, this is one proposition and this is one proposition. And in between same sign is there. So neither I can apply absorption law nor I can apply the distributive law. So what I will do, I will apply the associative law. In associative, I will take this P along with the first bracket. Associative changes the bracket. So now I have P or Q and P. Okay? And negation of Q. Now this, if you observe this bracket, if you apply the commutative, what you will get? See, I am writing here. So if you apply the commutative, P will come here and this will go here, right? And I'll have and negation of Q. Now here they are opposite and the first proposition is same. So I can apply the proposition law and we'll get P and negation Q, which is our answer. Hence we are done. Now look at the next question. In this question, I can make it out that outside this bracket there is one negation and overall outside this bracket also there is one negation. So let me apply it first De Morgan's to a big bracket. You can start from inside also, no issues. But if the number of terms increases inside, then it will be a problem for you. So now I'll apply negation of first bracket, which itself is made up of three proposition. Okay, and this or will become and then negation of Q. Now you apply double negation. So this will become P or Q and R. And this will become and Q. Right? So now I got this expression. Now next I need to work from this. Now what I will do in this first bracket, if I see this is one proposition, this is one proposition and this is one proposition. And again here if you observe, I have the same signs. So I am ruled out with absorption and distributive. So the only thing which can help me out now is associative. In associative also, which bracket will help me? If this proposition and Q are coming together, they can give me something. Because R is not at all related to this thing. Right? So what I will be doing here, I'll bring it here. So first if you want, you can apply the commutative and move this Q this side. And after that you apply the associative law. That will be much better approach. So now I am applying directly. So I am writing Q and P or Q. I have applied associative law and R. See, just brackets are changed. Now if you look at this one and apply commutative here, this is Q and Q or P and R. Right? Now here if you observe in this bracket, these two are opposite and first two are same. So it is nothing but absorption law. So this will become Q and R and we are done. Now let's move to the next question. Now, look at this question. First term is P or Q. If you want, you can keep it in bracket also. Or in this first bracket, these two are having the negation. So I can apply the reverse of De Morgan's law. So reverse of De Morgan's law means it will become P or Q because this has to be reversed. Also, I have and R. Right? Now, this considered as a single proposition. Now, I can see this sign is opposite. This sign is opposite. But I don't have the first two propositions same. Neither it can be bring by commutative. So, distributive law is the only thing which can help me. So, let me distribute this thing to these two. Okay. So, P or Q given to the first proposition. One term over. Then you should put the common sign. Then P or Q given to the other proposition. Right? So now in the first one, if you see, there is a proposition and negation of proposition. So if you have proposition and negation of proposition, 1 0, 0 1. So what is the or? This is 1 and this is 1. This is tautology. So T and P or Q or R. And we know that T and any proposition. Like if you have P any proposition and you have T 1 1. So if you take their and, it will be the same proposition P. Right? So here this is a proposition. So answer is P or Q or R. And hence we got our answer. Now let's move to the next question. Now look at this question. In this question, I can see two things. In first bracket, I can apply De Morgan's law and there is a conditional. So I can use the property of conditional. What are the two properties of conditional? If you have negation of P implies Q, this is equal to P and negation of Q. And if you have only P implies Q, this is equal to negation of P or Q. Right? So let me apply this, taking this as one proposition and this as one proposition. So when I'm applying this, so negation of first proposition. So negation of negation P or negation Q. Right? Then or should come. So I'll put or and then second proposition means this whole bracket. So I'll put P and Q and R. Now in this, I can see a direct De Morgan's law. So let me apply De Morgan's law. So this will become negation of negation P and negation of negation Q. Or P and Q. If you want, you can make it as single proposition also. Now this will be P and Q, or the other bracket has P and Q and R. Now observe very carefully. First proposition, second proposition, third proposition. Signs opposite. And first and second proposition are same. Means it is absorption law. So I can write P and Q as my answer. Right? Now let's move to the next question. Now the next question is P or Q and P or negation Q. Okay? And then or this should be like this because square bracket I can't see anywhere ending. So it should be like this. Okay. Now let us work on this question. Now if you observe this question carefully, there are four terms. And the signs are also working opposite. Means this is a distributive law as first proposition is same and P has been distributed. So let me apply reverse of distributive law. So P comes out like it is like taking common. We should not say here taking common, but usually it's taking common, right? So this we will have Q and negation of Q. And we have or Q outside. Okay. Now if you have Q and negation of Q, 1 0, 0 1, and I am taking AND. If I am taking AND, then what will have? 0 0. So it is F. Okay, and if you have any proposition 1 0 and you have F, 0, 0, their OR will be what? This is 1, 0. That is the same proposition. So I have P or Q and I am done. Right? Let's move to the next question. Now look at this question. I have P implies Q and this thing. So I have a lot to do here because so many negations I can see. The first term I can apply conditional. As I told you, this can be written as negation P or Q. Right? And look at the second bracket. If I properly arrange it, applying commutative law, this negation Q I am bringing here. So I'll have like this. Commutative I have applied in this bracket. Now you see opposite sign, first term same. So which is the law? Absorption law. So this will become negation of Q and here I have negation P or Q. Again apply the commutative and bring that negation Q in front. So negation P or Q. Right? Now I have opposite sign. But absorption cannot be applied because all three propositions are different. So opposite sign, all different, apply distributive. So apply distributive. Negation Q and negation P. Or negation Q and Q. Right? So I have Q, I have negation Q. 1, 0, 0, 1. So what will be and will be F. So F, anything or F is that thing. So negation Q and negation P. If you apply De Morgan's here, it is negation Q or P. And if I want to apply commutative here, this will become logically equivalent to negation of P or Q and I am done. Right? Now move to the next question. So my next question is this thing, negation of P and okay, before this let us do one more question which I should do because I need to do one question where I should have two conditional. So that will give you more clear picture how to apply conditional. Okay, let us try to prove this result. So now when I am applying this result, it's a very interesting question. I can see two conditional here, right? So first what I am doing, I am applying, I can start with this bracket or I can start as a whole also. So now let me consider these two as two proposition and conditional is sitting in between. So it will become negation P or Q implies R, right? Now negation P or here apply the same property again. So negation Q or R. Right? Now these two are same. So associative law can be applied. Associative law means only change the bracket. Now here I can see I have De Morgan's law. So this will become negation of P and Q or R. Now see the reverse of conditional. I can see the reverse of conditional what I applied here. When conditional was there, I did negation of this term and this term or this term, right? So now I have the reverse thing, negation of this or R. So this is P and Q conditional R. So I am done. Right? So now let's move to the next question. Now look at this question. Now let me try to explore. I have three parts in this question. Look at the first big bracket. In this big bracket, I have P, Q and R. So let me try to apply associative to bring these two negation things together and leaving behind R or, and here I can see this R is something repeated. So let me rearrange, maybe I'll get some law over there or R and P. Okay, so I'll take that as one so that I can work over there. Now here apply the De Morgan's law, negation P or Q and R. Okay, or here I can see this R is being distributed between P and Q. So R and P or Q. P or Q or Q or P, then you can apply commutative and make it same. Right? Now here again, if you observe, R is something which is common. Same. Right? So let me rearrange so that I can apply certain rule. So commutative law you apply negation P or Q close this. This is one proposition, this is another proposition, or here to R is here only, so no need to move it. Correct. Now you see opposite signs R being same means it is being distributed, right? So take this R and in bracket you will have negation of P or Q. Okay, or P or Q. So I can see the same proposition, one with negation and or is between. So if you have P and negation of P, 1 0 0 1, and we are taking or means 1 1 means it is a tautology, right? So I'll get R and T, and R and T is what? It is logically equivalent to R. So I am done, right? Move to the next question. Now look at the next question. It is big. It has two parts. So now let me start with the first part. Let me resolve first part, then I'll go to the second part. Now here this is a big bracket, and outside big bracket there is a negation, and in between there is a conditional. So see how I can think. This is one proposition. This is another proposition. Conditional is sitting between. Outside is negation. Means I have this type of thing. Right? And what is the answer for this? It is P and negation of Q. So first proposition I should write down. So P or Q and R is the first proposition. And then I should put and then negation of the second proposition. So negation of Q I got. Correct? So this is P or Q and R. Okay? And Q. Okay? So now I got this thing. Now further what I have to do, I have to solve this. So let me bring Q first this side. Because this Q should be close to P and Q, not close to R. I can see the same bracket, so associative will work. So Q and P or Q I will write in one bracket and R. Apply commutative here. So Q and Q or P and R. Now QQ same, opposite sign, so absorption. So this becomes Q and R. So we are done with the first part. So I have resolved this part. So now let us work for the second part. If you observe the second part, what you have? It's all negations. So apply De Morgan's law. So you can apply De Morgan's law inside also and directly outside also. So let me apply the De Morgan's law outside first. Second, I'll just make a space to do that second part. Now see, if I'm applying De Morgan's law here, what I'll be getting? Negation of this. So this will double negation will make it this thing. Okay, this or will become and again double negation it will become Q. So if you observe this, so I got somewhere here also. Right, so exactly same way you can solve and you'll get the same answer. So this question is also done.